Okay, so now in this video we're going to be talking about how to find the gradient of a straight line. Now I've got a definition here. It says that the gradient of a line measures its slope. Now slope is also a synonym for gradient, so you can kind of think of them as the same thing. Now up until this point we know that the gradient is the rise over run, and given a line, if it's shaped like this, as in it's leaning to the right, it's a positive gradient, and if it's leaning to the left in this way, it's a negative gradient. Now that's important to know, because if you do the rise over run, you need to know whether it's a positive gradient or a negative gradient. Like here, if we find the rise over run, I've measured this out. We've got a spacing of 1 for the rise, because it's the distance from this point to this point. So the rise is 1 to 2, so that's a distance of 1, and the run is 1 to 5, which is a distance of 4. So our gradient is 1 over 4. Now if it was facing the other way, but just mirrored, then it would be negative 1 over 4. So it's important to know that whether it's positive or negative. Now that's helpful, but we don't want to draw a graph every single time that we want to find the gradient of a line. So there's a gradient formula we can use, and that is that m is equal to the difference of y's over the difference of x's. And we've got an example here we'll do to give you an idea on how that works. Now what's helpful in order to remember this is that it's y's over run. That's just so because it's similar to the rise over run idea. That means that the y's need to be on top. The order of whether we have y2 or y1 first doesn't matter, or the x2, x1, as long as the 2's go first or the 1's go first and the y's are on the top. That's what has to happen in order for this formula to work. Now, we'll do this example to use this gradient formula. It says, find the gradient of the line joining points 2, 3 and minus 3, 4. So we'll give this one a go. First of all, I'm going to copy down this formula to help us remember and know what we need to put in. We have m is equal to y2 minus y1 over x2 minus x1. Okay, so now let's input these, but first let's label. We need to figure out what we're actually going to be working with. So this is going to be our x1, y1, x2, y2. Now it doesn't matter which one's which, as long as you've labeled them and you use them correctly with the formula. So now we've got that, let's input these values. So we've got y2, which is 4, minus y1, which is 3, over x2, which is negative 3, minus x1, which is negative 2. Now feel free to work this out in your head. Just for ease, I'm going to do it on the calculator. So first of all, we've got 4 minus 3, which of course is 1, over, we've got negative 3 minus 2, it's negative 5. So our answer is negative 1 over 5. That, of course, is a correct answer as well. This is just a neater way. I prefer to write it this way. So now we've got an idea of how gradients work and, of course, the gradient formula. Let's have a look at the angle of inclination of a line. That's the next thing we're looking at. So what does that mean? It means that the angle of a straight line makes with the positive x-axis measured anti-clockwise. There's still, even with the definition there, it's still a bit confusing. Essentially, if we think about this, we've got a line, that's the rise, that's the run. We know that that's the gradient, rise over run. Well, given theta, if we were to label these, this is our opposite, this is our hypotenuse, and this is our adjacent. We're going to have, for this, if we remember our SOHCAHTOA, it's going to be, for theta, we can use opposite over adjacent, which is tan theta. So tan theta is equal to rise over run, which is equal to m. So we can say that therefore m is equal to tan theta. We're going to do an example with this to show how it works. But before we get there, just be aware that for an acute angle, if it's acute, it's going to be a positive solution when we have our tan theta, and if it's an obtuse angle, we're going to have a negative solution, and you'll see that in the example as well. So, for our example of working with the inclination of a line, which is m is equal to tan theta, we're going to find the gradient of a line that makes an angle of inclination of 135 degrees. Okay, so let's unpack this a bit more. Well, we know that the angle of inclination is m is equal to tan theta. So that means if we're finding the gradient given the angle of inclination is 135 degrees, that m is equal to tan of 135 degrees. All we need to do is just pop that into our calculator. It'll spit out an answer for us. And we know our gradient. So the gradient for this line is m is equal to -1. Nice and easy. Without that angle of inclination idea that m is equal to tan theta, we couldn't do that with just the angle. We would have to figure out something a bit more. Now, for b, we have to do it twice. We have to do it for I and II. The question is, find correct to the nearest minute the angle of inclination of a straight line whose gradient is 0.5 and -3. So first of all, the 0.5. Once again, we know that m is equal to tan theta. But if we input what we know is the gradient. So the gradient is 0.5, and that's it, is tan theta. So that means we need to find this angle. Now, the way I like to remember how to find an angle is we press shift, because angles hide in corners, so that means that they're going to be shifty beings. You know, shifty beings always hide in corners. So if we do our shift tan of 0.5, we get given a solution of 26.565, etc. We want to make sure it's to the nearest minute, so we press the degrees, minutes, seconds button, and it says 26 degrees, 33 minutes, and 54-ish seconds. So that means that we need to round this up because it's more than 30. So our theta, once we do our tan -1, 0.5, which is equal to theta, our theta is 26 degrees and 34 minutes. Now we'll do the same for II. Now we'll notice a difference here, it's a negative, and for positive we can just input some values, work it through, and we'll get our answer. When we've got something that's a bit more interesting like negative, you'll see that there's an extra step that we need to do. So first of all, I'm going to rewrite the formula again. It's m is equal to tan theta. So that means our -3 is equal to tan theta. And once again, we'll type it into the calculator. We'll give us our theta, and when we pop it in, we get -71 degrees and, again rounding, 34 minutes. However, that's not what we want. We don't want a negative solution. So in order for this to make sense, I'm going to quickly draw it. And this is going to be a rough sketch, but it'll give you an idea of how this works. So given a line on an axis, let's just approximate here. If it's got a gradient of -3, it's obviously going towards the left, and it's going to be quite steep. So let's just say it's that. Now when we measure theta, it's from the x-axis anti-clockwise. So when it's negative, what's happened is it's found theta going clockwise. But we want, in order to find the angle of inclination, it needs to be this way. I'll do it in blue so you can see what we're trying to find. We want this. Now as you can see, that as this is a straight line and this is dividing it, we can find the opposite of what would make this work. So in this case, we're going to subtract 71 degrees and 34 minutes from 180 degrees. So when we do this, 180 degrees will take away the 71 degrees and 34 minutes. We get 108 degrees and 26 minutes. And so that's our true theta. That's our actual angle we're looking for. So the final idea that we're going to look at in this video is the gradient-intercept equation of a straight line. Now, in prior years, you may have recognized something like this, where we have y equals mx plus c. C is a constant, and m that's our gradient. It's to be consistent with what we've been doing before, and c is our y-intercept, which is the constant added on at the end, which is just a number with no x at all. So using this idea, we can answer this example here. For A, find the gradient and y-intercept of the linear function y equals 7x minus 5. Now, linear function just means a straight line. So given this information, that's all we need to answer this question. So for A, m, which is the number in front of the x, m is going to be 7. And c, it's the number by itself, is negative 5. Remember that if there's a negative there, it has to go with it. It's the whole number added on. It could be whole number, decimal, whatever's extra with no x, added or subtracted, that's what we need to chuck in for our y-intercept. Now for B, find the gradient of a straight line with the equation 2x plus 3y minus 6 equals 0. It's the same question, worded a bit differently, but the equation isn't in the form that we want, which is the gradient-intercept equation. What we need to do is get it so we have y by itself and everything else separate, and it will give us our m and our c. So let's do this. First of all, I'm going to rewrite it. That's so I've got a nice starting platform to work out everything that I've got here. Now, first of all, I've got 3y here. I want to focus on that and maintaining it on this side and move everything else onto the right-hand side. So I'm going to do it step by step. First of all, I'm going to get rid of this negative 6. Now, in order to get rid of it, I'm going to add 6 to both sides. So when we do that, we're going to be left with 2x plus 3y on the left-hand side, and on the right-hand side, we're just going to have a 6. Next, I want to get rid of that 2x. I'm going to take it away. I'm going to subtract 2x from both sides. Doing so leaves 3y on its own on the left-hand side, and we've got minus 2x plus 6 left on the right-hand side. Now, I could have put minus 2x on the left side of 6 or the right side. I put on the left side to keep it consistent with this form. That's why I've done it that way. Now, the last step is to get rid of this 3. Now, a lot of people make a mistake and just divide it by the negative 2x in this situation. We need to divide it by absolutely everything. So we divide by 3. We're dividing 3y by 3, which leaves just y, minus 2x by 3, which leaves minus 2 on 3x. And then we've got a positive 6 on 3. Now I can simplify this up. We're going to have y is equal to minus 2 on 3x plus 2. Now, this might look unfamiliar to some people. You might have done minus 2x all on 3. It's all the same. I've written it this way so you can easily see that minus 2 on 3 is the m, and then we're left over with the 2. So if I'm going to write this out, showing what m and c is, our m is minus 2 on 3, and our c is a positive 2. So there you go. We've gone through the gradient-intercept equation of a straight line, how to find the gradient of a straight line, the gradient formula, and the angle of inclination of a line.